Assalamualaikum students. Students, in today's lecture, we are going to do the spontaneity of a reaction. Spontaneity means is the reaction is going to occur at this temperature or not. Like for every reaction, like we talk about certain temperature, definitely. At room temperature, not possible, then maybe at high temperature, not possible, maybe at low temperature, like depends, right? So if a reaction is occurring at that temperature, we say it's spontaneous at that temperature. If not occurring, we say not spontaneous. But for spontaneity to occur or not occur, we used to find delta G, which is called what? Gibbs standard, Gibbs free energy, or simple Gibbs energy, Gibbs function. Now, if delta G is negative, the reaction is spontaneous at that temperature. If the delta G calculated is positive, the reaction is not possible. But what is delta G? Actually, delta G is the combined effect of temperature delta H and delta S. The spontaneity of a reaction depends on the temperature at which the reaction is occurring, the delta H of that reaction, the entropy change. All these three things decide that whether the reaction is feasible or not feasible. Now, listen, the combined effect of all these is in delta G, which is delta H minus T delta S. You're supposed to know all these things, but the derivation of delta G is not in the course. We can derive it from total entropy. The total entropy depends on system and surrounding. But in our course, we are not supposed to know this. We must know that what is entropy, what is the change in entropy, which is product minus reactant. And if there is certain reaction, it has certain delta H, there is certain delta S, there is some temperature of the same reaction. All these three things are combined and the delta G. The delta G is equal to delta H minus T delta S. If the delta G is negative, it is spontaneous at that temperature. If positive, not spontaneous. Now, let me explain it. Like, I'm not going to go in more detail of that thing, but once again, a slight revision. The delta G is equal to what? Delta H minus T delta S, right? So, if the delta G calculated is negative, spontaneous, positive, non-spontaneous. Secondly, if I rearrange it, if I rearrange it and I make the delta H subject, delta H is delta G plus T delta S. So can I say that delta G is part of the delta H? Yes. If there is a reaction, I'm just trying to a little bit link it. This is a closed container. This is the piston. There is some specific pressure and everything. We're not changing anything. The reaction is occurring. It's a closed system. And it is producing heat. You know what will happen? Delta H. Some heat is used in pushing the piston upward. So when there is some pressure on the piston, it will move upward. It will cover some distance and force is applied. So is it work done? So some of the heat is used in that work done. And some of the heat is T delta S. Keep in mind. Some is used in work done. The amount of the heat and work done is actually delta G. But all these things are not included. We are just supposed to know that delta G is what? Delta H minus T delta S. But then why I am explaining, I'm just trying to link the delta G to delta H, that the unit of that delta H is what? Kilojoules per mole. The same is the unit of delta G, because delta G is part of delta H. This must be equal to kilojoules per mole. Look, delta G is equal to delta H minus T delta S. It is kilojoules per mole. Kilojoules per mole. Temperature, Kelvin. This is joules per Kelvin per mole. Now what will happen? The Kelvin and Kelvin cancel. What is left? Joules per mole. So now you are supposed to divide it by 1000 to convert this into kilojoules. So in every question, to find spontaneity, you are supposed to calculate delta G, and you know that delta G is equal to delta H minus T delta S over 1000. Why divided by 1000? To convert the joules into kilojoules. And if your delta G is negative, it is spontaneous. If it is positive, it is non-spontaneous. It is non-spontaneous. Now, I'm going to solve a question with you people. Look at this question. These are my topicals. These are available on my website. These are all the questions of entropy. Like, it will help you a lot. So after the notes you will find on my website, and the papers will also. The topical papers are there on my website. Okay, and the name is Chemistry by Zeenat. See this question. Whether or not a chemical chain reaction is spontaneous feasible can be deduced by calculating the delta G at given temperature. Now, calculate delta G at 298 for this reaction, whose delta H and delta S are known. Now, look, delta G is equal to delta H, how much? 117. Delta H minus T, 298 Kelvin into 175 over 1000. Now, if my answer is something positive, I'm not calculating, this is your job. If I get positive, what they are saying, use your answer to explain whether or not this reaction is spontaneous at 298. If positive, not spontaneous. If negative, spontaneous at 298. And this is not the only question. There are many more questions. See? Okay, listen. This is the reaction whose delta H is given. And they are saying, calculate delta G for this reaction at 298. Now to calculate delta G, I need what? Delta H, which is given. I need temperature, and I need delta S. So how you can find delta S? Product minus reactant. Look, delta G is equal to delta H minus T delta S over 1000. So, do you have delta H? Yes. Do you have temperature? Yes. Do you need to find delta S? Yes. You know what is delta S? The delta S is product minus reactant. So, it is product minus reactant. It is 26.9 plus 214 minus 65.7. See? Now, can I do it this way? Look. Delta G is equal to delta H, how much? 117 minus 298 into 26.9 plus 214 minus 65.7 over 1000. If my answer is negative, spontaneous, positive, non-spontaneous. You know, in the next part, what they are saying? Explain with reference to delta G why this reaction become more feasible at high temperature. You know what will happen at high temperature? At high temperature, if I write it here, at high temperature, if I use a larger value of the temperature, this whole negative factor would be large and the reaction would be more spontaneous. See, more the temperature, this whole negative factor become large as compared to this positive. The delta G would be negative. So what you are supposed to write? More feasible. Why this become more feasible at high temperature? Because at high temperature, you know my answer, at high temperature, minus T delta S is large negative as compared to positive delta H, the reaction is spontaneous, right? So I hope you understand that how to calculate delta G, right? Like there are some questions in which they have given you what? See, they have given you delta H, delta G, temperature. See, in this question, if I erase this, look at this whole question. Predict the sign of delta S for this reaction. To predict sign, you're supposed to see what? The physical state, they're all same. So we can't use physical state to find the delta S. So what am I supposed to do? I will count the moles. 2 and 1, 3 mole gas making 5 mole gas. This more chaos, more disorder, the delta S is positive because more moles of gas. In the next, the free energy change, delta G, at 1000 Kelvin is 51. So delta G is what? 51. Delta S, delta H is what? 241 minus 1000 Kelvin into delta S over 1000. Can you find delta S? Of course. Right? Now we have the relation of delta G and temperature. There are 4 cases. There are 4 types of graph. See? There are 4 types of graph. There are 4 types of relation of delta G with temperature. But these relation depends on delta H and delta S. How? Look. If I just focus on the formula, there is possibility. There is positive and it is also positive. There is possibility. The delta H is negative, delta S is also negative. There is also another possibility. The delta H is positive, delta S is negative for the reaction. The delta H is negative, delta S is positive. So we have 4 cases, right? in which we have to talk about the rule of the temperature, right? You know what is the first case? What is the first case? Delta H is negative, delta S is positive. See? There are four cases. Delta G and temperature. The first case is what? The delta H is, what I have written over there, I forgot. Wait a minute. Delta H negative, delta S. Delta H is negative for the given situation. The delta S is positive. A reaction which is exothermic but with high entropy in the product. You know, such reaction, delta G is equal to delta H minus T delta S. You know, it is negative. It is negative in the formula, temperature, it is positive. You know, these two things are multiplied. So minus into plus is minus, and the sum of the two negative is always negative. Like if I ask you minus 100 and minus 200, the answer is what? Minus 300. This is product plus into minus, minus, minus and minus. The sum is minus. Larger the temperature, more negative. If I plot the curve of what? This is delta G 0 plus minus, this is temperature. Look, the temperature increases this way. At every temperature, negative and negative is always negative. But if the temperature is low, less negative, high, more negative, more negative, more negative, becoming more spontaneous, more visible. The delta G is negative. It is always negative. What is the second case? The delta H is positive and delta S is negative. A reaction in which the delta H is endothermic with less disorder in the product. Such reactions are not possible at any temperature. Such reactions are possible at every temperature. Low temperature, less negative, more temperature, more negative. You know, if it's this case, never possible. Why? Delta G is equal to delta H minus T delta S. Minus into minus is plus. It is always positive. Now its graph is total opposite kind of reflection of the upper one. This is temperature, 0 plus. So more the temperature, larger positive. It's like this. Not possible at any temperature. Next. If both are positive, look now. If both are positive, case 3. The delta H is positive. The delta S is also positive. Now, delta G is equal to delta H minus T delta S. Now, there are two possibilities. Look, there are two possibilities. How? How two possibilities? If the temperature is large, this whole factor is large negative. Minus T delta S is large negative. as compared to positive delta G, large negative. The overall delta G is negative. But if this temperature is small, this whole factor become small minus T delta S is small negative, then positive delta H, small negative then positive, the overall is positive. Large negative then positive, the overall is negative. So what is the meaning of this? At low temperature, not feasible. At high temperature, feasible. How you will plot a graph, straight graph, positive, negative. This is temperature. So what we are supposed to say? At low temperature, it is positive. At low temperature, this is low temperature. This is high temperature. At low temperature, it is positive. Right? From positive, less positive becomes zero. What is the zero thing? The delta G zero. This is the equilibrium. You know, if the graph is this way, suppose this way. You know, this temperature, this is the temperature at which delta G is zero. So if delta G is zero, this is equilibrium temperature. Or if the process is a physical change like melting and boiling, it could be equilibrium temperature, it could be melting point or boiling point, because at melting, solid and liquid are equally existing. At boiling point, liquid and gases are existing. They are equilibrium temperature for physical state changes. At this temperature, the delta G at equilibrium, it is very low. So we say it's zero. Right? Now, if I show the notes at the same time so that you're familiar. Look, case 1. Such reaction are spontaneous at every temperature. At low temperature, less negative. At high temperature, more negative. Now, not possible this case at any temperature. Why? From positive to more positive. Both are positive. So what you are supposed to say? At high temperature, minus T delta S is large negative as compared to positive delta H. You have such theoretical question for which you need to have such answer. And why I am giving you notes? Because most of the time I've seen that when you describe this, you are poor at the description. So no worries. Like, we are not perfect at everything. Sometimes we teachers, when we write a statement, if we are not exact careful at that time, we may make mistake. So you must be very careful. So what I used to do, that minus T delta S is what? Large negative as compared to what? Positive delta H. Large negative, your overall answer is negative. Small negative as compared to positive delta H. Small negative at low temperature as compared to positive delta H. The result is positive delta G. So at low temperature, the delta G is positive. At high temperature, the delta G is negative. And what is that temperature? At this temperature, the reaction is in equilibrium, the delta G is zero, and if the change is a physical state change, then it is melting at boiling point. Like, read your question carefully, that you are dealing which type of reaction. Is the reaction just a physical state? Yes, there are some 1 or 2 questions in your past papers. Now you know what is the next situation. Both are negative. So what is your first case? Delta H negative, delta S positive. Spontaneous at every temperature. Delta H positive, delta S negative, not possible at any temperature. both positive, both positive. At high temperature, the delta G is negative. At low temperature, the delta G is positive. And what is the next case? Both are negative. If both are negative, look, delta G is equal to delta H minus T delta S. Delta G is equal to delta H minus T delta S. Negative, negative, minus into minus, plus. If the temperature is low, the minus T delta S is small positive. Right? If temperature is low, minus T delta S is small positive as compared to negative delta H. So the delta G would be negative, spontaneous at low temperature. At high temperature, when the temperature is more, the minus into minus, this plus factor is large as compared to negative delta H. Delta G is positive, the reaction is not feasible at high temperature. The reaction is not feasible at high temperature, positive. The reaction is feasible at low temperature. This is equilibrium temperature. So the graph would be like this, straight line graph, right? Look at this question. The evaporation of, read this, the evaporation of water, liquid into gas. Now when you evaporate water, you provide heat, it's endothermic. Positive. There is gas, delta S is also positive. Both are positive. If both are positive, the delta G is positive at low temperature, negative at high temperature, zero at equilibrium. It's liquid to gas, the boiling point. Sketch a graph on the, okay, what they have written in the beginning, the evaporation of 1 mole of water, evaporation. The delta G is this much at 25. Sketch on the graph sketch a graph on the axis to show how delta G changes when the temperature changes from 25 to 150. So at 25 it was water turning into gas, more the temperature becoming less positive. At 100 the delta G would be 0. Above 100 when it is gas, above 100 when the temperature is more, the delta G is equal to delta H minus T delta S. When the temperature is more, the negative factor is large, the delta G is negative. Right? At the same time, there is also another question. Look, wait, before going to this question. You are starting from this and you have to pass it through 100. Why through 100? Because you are turning a liquid into gas at 100 degrees Celsius. This is considered to be equilibrium temperature because at 100 degrees Celsius, both water and steam are in equilibrium. They both exist. So you have to pass it through 100 so that the delta G is 0. Do you get my point? You're starting with 8.6. When the temperature will increase, it's like this. If the temperature is more, this is more negative, is the result the delta G is negative. When the temperature is less, the negative factor is lower, the positive would be more, it becomes positive. So at low temperature, delta G is positive, at high temperature, delta G is negative. And at this temperature, it is an equilibrium. It is either equilibrium temperature or melting and boiling. And this one is opposite, and then we also did this situation, this question, this is from past papers. The reaction between A and B is feasible at low temperature, not feasible at high temperature. Feasible at low temperature, not feasible at high temperature, shows that both delta H and delta S are negative. And now you're supposed to explain it this way. You know what is your next topic, the last topic? How you can find, look, we say that this reaction, if delta H is negative, delta S is positive, feasible at every temperature, not feasible at any temperature. Feasible at high, but not feasible at low, feasible at low, but not feasible at high. The question is, how can I calculate that at which temperature it becomes feasible? So actually the question is phrased like that. Look, like suppose this is the situation. It is not feasible at 1060, at 1080, or 1011, but after this, it is feasible at every temperature. So how can I ask you that calculate which temperature? Calculate the minimum temperature, minimum. Why? Because after this, it is feasible at every. So if both are positive, the Cambridge, the Excel will phrase their question like this, that calculate the minimum temperature, because they know that after this, it is feasible at F. But if both are positive, you know how they'll phrase both are negative, how they will phrase their question. Feasible at 1060, feasible at 1060, 1080, 1100, 12. But after this, it's not feasible at any. So what they will ask you? Calculate the maximum temperature. So if both are negative in the paper, they will ask you to calculate the maximum temperature. If both are positive, they will ask you to calculate the minimum. You're not supposed to know. Like this will be the question statement. Find the maximum or the minimum. Now the maximum and minimum depend on the situation. If both are negative, the question would be calculate the maximum. If both are positive, calculate the minimum, because we know that after that it is feasible at every high temperature. Maximum, we know that before this it's feasible, but after this it is not feasible. So what you are supposed to do is assume that the reaction is in equilibrium. Assume it is not. If I assume it, my delta G is what? 0. If I know delta H, if I know delta S, I will get the temperature directly in the Kelvin. Right? Look, this I've given. Calculate the minimum temperature at which this reaction is feasible. Why they're asking you minimum? Because both are positive. They have to phrase it like this way. So I know both the values. I know delta H, I know delta S, I know the 1000 conversion thing. I can find temperature. I have to assume that it is 0. So the temperature is how much? Oh, sorry. The temperature I got was this much Kelvin. Since Celsius is given, I have to convert the Kelvin into Celsius. Right? But if they don't ask you Celsius, the answer was this. For Celsius, it is converted. And there are more questions like this in your past papers. So we have these 4 situations, right? At the end, that if positive, negative, not spontaneous, negative, positive, always spontaneous, both positive, spontaneous at high temperature, both negative, spontaneous at low temperature. And at the end, you can find temperature. If you know delta H, if you know delta S, assume delta G0 is equal to delta H minus T delta S over 1000. Right? Your chapter is over. Do the practice. If you want to know more, you can join my live sessions. For that, you need to contact me. All the information are given on my website, Chemistry by Zeenat, the notes, topical. And before leaving, don't forget to like, subscribe, and share my channel. Bye.